Hello everyone, my name is Meir Vengrover. I'm working in Applied Materials, Israel. In this lecture, I want to talk about how we can take Python and use it as a common language, a bridge between algorithm team and software team. I want you to understand that it is not only a technical issue, it was a complete revolution for our development process. We all know that Python is a great language. You can make many cool things in Python. But in Applied, we asked ourselves, can Python change our development process? Can it boost our delivery? Can it cause us to shorten the cycle of solving bugs? Can it break walls between separated teams and cause a joint creation? And the amazing answer was yes. Python is indeed only programming language, but by making Python a common language between algorithms team and software team, we can achieve all these targets and more. In the following minutes, I will take you to a short journey and I will show you the process we went through and the wonderful results of this process. I will show you our motivation for this process, the reasons for choosing Python as a common language, and the recipe for a joint development around Python that you can take and apply in your company. In order to give you a short background for our subject, I will tell you a few words about what we are doing in Applied Materials. Applied Materials is an American corporation that supplies equipment for the manufacture of chips for electronics. In Israel, we develop process control machines for this industry. Our machines take care that the chips you have in your electronic devices, your cellular phone, for example, will be produced properly. In order to do so, we have machines which contain huge microscopes, which take images, photos of nanometer-sized patterns inside the chip. In our software group, we process and analyze the images, and we give our customer an analysis of the quality of his process. Using image processing, we measure the pattern size inside the chip and find defects. So our software group is dealing a lot with image processing. For this, we have two separated groups. We have the algorithm teams. These are smart people with second or third degree in mathematics or physics, which develop great image processing algorithms. And we have the software team. These are also smart people from computer science or software engineering, which take the clever algorithms from algorithm team, integrate them in the image processing flow, and create great software for our machines. By the way, I'm from software side of the table. I'm team leader of such software group. For many years, the algorithm team and the software team were used to code in different languages. The reason for that was the two groups have different needs. In algorithm, they needed a language that can give them the ability to develop a solution fast and to test it in a proof of concept environment. They don't want to invest in designing and building a glorious software. They just want a language which has enough scientific tools and enables them to develop the algorithm which solves the problem. So they chose MATLAB. MATLAB is a standard in the university for research. It is high-level language with minimum code overhead. You can develop your algorithm very fast. It was built for vectorial operations. It has great scientific toolboxes and great ways to visualization for your algorithm result. Really, it's a heaven for algorithms developers. In the software team, we think about other aspects. We want natural object-oriented language. We think about software design and design patterns. And the most critical need is performance. We must create software which run fast. If the software will not run fast, our customer will get slow machines. They will not be able to produce many chips, and eventually they will throw us away and buy other products. Time is money also for our business. So in the software, we chose C++, which is great object-oriented language and well known for its great performance. In C++, you can write a very efficient code, which runs fast and control memory consumption. Okay, no problem. Algorithm team will write their sophisticated algorithm in MATLAB. Software team will write their code in C++. Great. I would ask you this question, if it's great or not, but this is a recorded session, so I will answer it by myself. No, it's not great. The problem starts in the moment that we need to integrate the sophisticated algorithm, which was written in MATLAB, inside our software solution. We don't want to have pieces of MATLAB inside the C++ code. It is bad design and bad performance. So here starts an exhausting process of translating the MATLAB code to C++. A long process with a lot of ping-pong reactions between the algorithm and the software teams. But the translation process is not the end of the story. What will happen if we found a bug in the code? Yeah, that happens. What if we want to improve something in the algorithm due to some issue we found? We need to get back to algorithm team and ask them to fix the bug. But the bug was found in the C++ code, so we need to find the equivalent code in MATLAB. If we have the inputs for the C++ algorithm, we need to create proper inputs for the MATLAB code in order to reproduce the issue and try to fix it in the MATLAB. After fixing the issue in the MATLAB, the software team need to translate the fix back to C++. In order to do this fixing process, we have to maintain the algorithm in both MATLAB and C++ all the time. Sometimes we decided this conversion process was too expensive, and we decided to keep the algorithm in MATLAB and rewrite only critical time-consuming pieces of it in C++. It means that our code became C++ and MATLAB mixed, very complicated, and we had to develop MATLAB C++ connectivity ways in order to negotiate between the languages. We created a complicated solution which is very hard to maintain, a big mess. Do you remember the Tower of Babel, Migdal Babel story in the Bible? In this story, the citizens of Babel built a tremendous tower as long as they talk the same language. Once God mixed their languages, they couldn't proceed. They could not understand each other. One said to his friend, "Please give me a nail," and his friend dropped a hammer on his head. Apparently, if you want to build a tower, you need to speak the same language. And we also go to this conclusion. If we want to build our image processing solution properly, we need to use the same language. So we chose Python as our common language between algorithms and software. From now on, the entire image processing team will write only in Python. Why Python? Python has great advantages for both algorithm and software teams. For algorithm, it is easy and straightforward to write in Python. You can develop your algorithm fast and prove your concept fast. Python has enough scientific packages in its ecosystem in order to do all you want to do in algorithm. Till now, we didn't have any function in MATLAB that we didn't find an equivalent function in NumPy, SciPy, scikit-image, etc. But Python also became a standard language for algorithm development, especially in the deep learning area. Deep learning is a great buzz in the industry. Many algorithms are using deep learning. And all the most common used packages for deep learning have API in Python, like TensorFlow, etc. For software, Python is also a comfortable language for software developers. As you know, you can write beautiful projects in Python. Python object-oriented abilities are not tough as C++, but it's okay for us. The coding in Python is much easier. You can write your solution very fast and increase your velocity. Since Python is a higher level language than C++, you can maintain it much easier. You will not get memory leak because you forgot to release some pointer. Also, for software development, there are great libraries for doing everything you wish to do. You can easily debug and fix the Python code. No need compilation. Just put your fix in place inside the code and check the effect. Actually, much better life than C++. But what about performance? As you remember, one of the main reasons for choosing C++ in the past was its amazing performance. Can Python compete C++ performance? This was our main concern, and we found out that when writing efficient code in Python, you can reach very close performance to C++ performance. Good enough for our software. The software team took responsibility to learn Python performance optimization, review the code, and boost its performance. What we can do in order to keep Python code performance close to C++? It's a completely different talk, only a few tips that make it possible. You should use efficient NumPy matrix operation. Try to avoid loops, Python loops. It will kill your performance. Reduce memory allocations as much as possible. Try to avoid creating new vectors by preferring NumPy in-place vector operations as much as possible. Redundant memory allocations can harm both throughput and memory consumption. If needed, get help from packages such as Numba, which compile the Python code to C++ and run C++ behind the scenes. I would like to present our new development process around Python. You can copy-paste it to your company. No need to pay us royalties. The great thing in coding with common language is that the two development groups can work now together, shoulder by shoulder, on a common code. The process goes like this. First of all, the algorithm developers write their algorithm initial code. This code is not well designed and not efficient, but it works. At the same time, the software developers prepare the place in which the algorithm code will be placed in the flow, the algorithm envelope. Next, algorithm developers and software developers review the code together. The software developers help to clean it and make it readable and well-designed code. In addition, we are making performance session. Software developers help to boost the code and make it throughput and memory efficient. At this stage, the code is ready for integration inside the software. The integration is also being made together. Finally, we have Python code inside the production software. The algorithm code itself is under algorithm team responsibility, and the entire flow is under software team responsibility. Clean, well-designed, well-performant code. Using this process, we reach these achievements. No need for language translations. MATLAB to C++, C++ to MATLAB. We work on the same code in the same language. Huge development, time saving. Since the algorithm code itself is part of the production code, when there is some issue with the code, the algorithms developers can see the issue immediately in their code, fix it in place, test, and deliver the fix by themselves. No need for software intermediation and translations. Short bug cycling fix. This is very important advantage. no language mix. There is no C++ code that called MATLAB or MATLAB code which calls C++. No need for language connectivity mechanisms, only Python. It reduces code complexity. In addition, the code looks clean, unified, and well designed. No pieces of code which artificially connected together. It's a big design bonus. We broke the wall between the groups, between the algorithm team and the software team by building the Python Golden Bridge. The work together became tight. The two groups work harmonically together and promote each other. This is really great. In addition, since the software review the code together with algorithm, they get familiar with the code better. It's not a black box for them. This knowledge is critical when a customer has some problem with the algorithm and the developers are required to guide him how to use the algorithm parameters wisely in order to get best results. The solution knowledge gets deeper. Software developers get algorithm development knowledge, and algorithm developers learn how to write great software. This common knowledge enrichment is also a great thing for our developers. So in the beginning, we asked if we can use Python not only as cool language for cool projects, but also as a language that will change the development process. I presented the process we went through in applied materials, and I showed you how we took Python and used it as a common language between software and algorithm. By doing that, we changed completely the development process and boost both the development and delivery process and shorten repairing cycle. I showed you how Python can also be the glue which creates one healthy group of developers which work together on the same code. It's really amazing that we could achieve all these achievements using Python as a common coding language. We broke the wall between the algorithm and software. You can make it too. I encourage you to recommend this idea also to your company or to other companies you have in mind. If you want to ask me any question about this lecture, I put a link in the chat to a breakout room. We can meet there. Thank you everyone and enjoy your next lecture on Python.